Okay, and we should be live. Um, so hey everyone, this session is about system image for servers. I've got a few folks here from the Foundations team who's responsible for mostly designing the system image system and how we make our images, as well as James Page, I guess representing the server team in this meeting. Okay, so maybe a brief overview of what system images are before we go and discuss how they might apply to the server. So system images are basically what we do for the Ubuntu phone, where we build everything. Just hold on a sec. Yeah. The tab open with YouTube. That wasn't so good. So yeah, we build an image on the server side, then we basically stream that image as tarballs on the actual devices. That gives us the advantage that every single Ubuntu touch device that runs on the same piece of hardware is basically guaranteed to have exactly the same content as the others. It also allows us to do delta-based updates where we can just generate a server-side delta tarball that gets sent to the client side and then applied. So that has some clear advantages over using apt-get for some cases, and it works great for the phone. And a while back, I think like a couple of months ago, Mark asked the Ubuntu technical board to look into what can be done to use system images for the rest of the Ubuntu ecosystem. One of the first targets we've been looking into is how that could apply to server, or at least some subset of what people do with servers nowadays. So that's basically what this session is about. Not sure if anyone has like initial comments, questions before we go maybe into more details as to what we can do.
It's maybe worth adding that we explicitly agreed that it would never be in the table to disable apt. So just to assuage anybody's doubts, nobody is talking about killing off apt or anything like that. Even as I understand it, for the desktop, there'll always be an option to disable to make your image writable and then manage things the old-fashioned way.
Right. I mean, the main idea here is to make it easier for some people with some specific workload, which might at some point mean most of our users. But we definitely don't want to make it any harder on people who are currently used to how things are. Okay. So one thing we discussed a bit offline with some other folks is basically what kind of test image we could build for the server using system image. Obviously, we can't possibly cover all of the possible workloads to begin with. I think the best way, at least initially, is to provide us really small image that's basically just a base Ubuntu server image similar to what we have in cloud instances, using system image to manage and update that, and then basically go from there, see what we can plug in there and how we can deal with actually running workloads on top of that thing while still having the rest being updatable.
So Mark suggested Ubuntu Core. To be exact, he suggested calling it the Ubuntu Core image. I think we could probably build something useful that looks quite like Ubuntu Core, as in the current tarballs that we produce particularly for hardware bring-up purposes. I don't think it could be identical. We'd need the system image machinery in there. We'd probably need click in there for it to be useful.
Yeah, also
maybe
and a bootloader would be nice.
Or something. And a bootloader. There's that kind of thing that's difficult. The case of one thing that's particularly difficult that we haven't really had a need to care about on the phone is that the bootloader is not. So right now we install a bootloader dynamically depending on your system. This allows us to have the same image for EFI and BIOS. On system image, can we do that? Is it actually possible to deliver a common EFI BIOS image? Because we're going to need a different bootloader.
Well, let me ask a different question. Do we think we care about delivering BIOS compatibility, or should our initial target for this be EFI only?
So
again, we're not trying to be everything to everyone right now, so maybe we should just be targeting.
Sure.
So while I'm really a fan of going legacy-free, and legacy-free is great, I think the issue we would hit pretty quickly is that people who want to actually test that thing are probably going to test on older hardware or in VMs, where assuming EFI is not necessarily something we should do.
There's also stuff like we'll probably need to make /boot writeable, because that's written to by Grub install update Grub on kernel updates, and some of that is well, everything assumes it's writeable essentially. But
well,
that's fairly easy to do.
Even that depends. If we assume that your system can't be multi-booted or anything, just has a single operating system on it that's meant to boot, say, from a USB key or something, /boot itself could be read-only and part of the image, because you won't install a new kernel, you won't change your boot config, so we can actually ship with grub.cfg built during image build time.
Sure. That's true. Although Grub install still has to be run. Yes,
because yes. It actually writes the MBR or equivalent. Yes.
Well, you have to run it on major Grub updates. Yes, you can get away with it without running it sometimes, but you ought to run it. The one thing that comes to mind is maybe we can just install all the bootloaders. We can't quite install all the pieces. There are some conflicting bits at the top, but a while back I did some work to make at least most of the binary elements co-installable, so you can at least have support for installing a variety of bootloaders, and maybe we could do that.
Yeah, and what we will probably do there is basically what we do on the phone is that on the phone, if we need to change your kernel, we basically ship the TMG file as part of the device-specific table, which then triggers the actual upgrade of those partition images. Obviously, that wouldn't work for, well, it's probably not how we want to ship an MBR change, but what we should do is have the upgrader basically run grub install or the relevant bootloader command to actually reinstall the MBR or the EFI binary every single time we run an update, just to be safe.
Right. So I mean, I think we probably could just install grub PC bin, grub EFI AMD64 bin, maybe actually grub Zen bin, given the targets, and grub install will, I think, nowadays mostly pick the right targets if it can, and if it doesn't, it's relatively easy to overwrite that kind of thing. So yeah, maybe there are some useful things we can do there.
So Loic is asking on IRC whether we can do everything from a specific inlet instead of relying on a bootloader. But I think he's asking specifically about the switch between booting into recovery or flash or upgrade mode, or just booting the actual system. And that's not even what we're discussing now. We're just discussing how we can actually make that thing boot.
You have to have something in the MBR, so we have to have some way to install a bootloader, and it should be Grub.
Yeah, the actual upgrade environment. So what we do on the phone, and that's probably not what we want to do on the server, is we basically have a tool in the system that downloads the update in a specific part of the file system, then reboots the system into recovery mode. The recovery environment will detect that we have a pending update, then apply it, then reboot back into the system. That works for the phone. The obvious issue with that is that it requires a reboot, which is not necessarily something we want to do on servers. One thing, however, that we have in the system image spec is, I think it's called bootme, the actual flag. So we've got one flag that we can add to an image saying that this specific image requires a reboot. So we could potentially have the upgrader on servers, basically apply the update directly to the file system. So basically clone the mount namespace into a separate mount namespace, run the upgrader inside it so that it can remount / read write without any outside process noticing that it's been remounting read write. Then apply the update there. And only if we have a bootme flag set, because say we updated the kernel or we updated some bit of security relevant libraries that we prefer to reboot just to be sure, then we can decide that this update should actually be applied offline and then we reboot into the upgrader mode.
Yeah, I mean this sounds cool. I'd like to see a prototype of it to see how it performs in reality. But yeah, it sounds like a promising approach.
Mm-hmm.
So system image itself has that last step of rebooting into the recovery is basically implemented as a hook. So assuming that we have some other thing that we can call, which may or may not be part of the system image package itself, it should be fairly easy to have a, more of like a server or desktop, hook implementation that wouldn't actually try to reboot it to recovery. So that last step of actually applying the thing that's been downloaded shouldn't be too hard to hook in, assuming that we can write that step as a separate entity. Does that make sense?
Yeah, no, it makes sense, and yeah, indeed, we could have. It's been designed pretty much from the start so that we can have different mechanisms depending on what kind of target platform we're running on to apply the actual update.
So can I ask a question specifically about what happens to apps during upgrades? Presumably their state is lost, and once they reboot, you have to restart them to get them back. Sorry, I don't know much about the code, so some of these questions sound a bit dumb. Excuse me.
This would only work at all sensibly with things that are packaged either using Click or using some kind of containerized thing that lives in a separate environment. You'd have to. So there wouldn't be a way to use apps on top of system images unless you make the image writable.
Yeah, that's fine. I'm comfortable with that. I just kind of wondered how we might manage the transient state of those applications during a system upgrade. So whether there's a kind of freeze, upgrade, reboot, resume type cycle we go through, or whether you have to basically restart the containerized application after a system upgrade that requires reboot. I'm just trying to think how this might flow for an end user ultimately. So.
Yeah, so my best guess there is that for the most case, we would basically do the same thing as apps does nowadays, which is just apply the update to the file system and not really do anything more than that. Obviously, it would be nice having a way, possibly an extra flag in the image that says exactly what needs to be restarted, if anything, and then have apps possibly be restarted if that condition matches. We could have, so currently we've got the bootme flag, which basically means you need to reboot the old system. It might be nice having some other flag that says you need to reboot the actual apps on it, but not the system itself.
Well, I wonder if that makes sense, having that be part of the system image metadata and not just the app metadata themselves. Because you might have, for example, one app that needs to be restarted, but that's one of 10 apps that sort of get up.
Well, what we would probably have to do then is have the upgrader on that system offer some way for apps to hook into that, so that they can say, hey, if you change one of those paths, please restart me. or something along those lines. But yeah, it's information we have, and we could make that happen.
So can I ask, are we actually slicing things a little bit too finely by trying to distinguish between restarting all the apps versus restarting the system? Because in this context, the system itself isn't really providing any services, except perhaps, I suppose it might have a kernel level, there might be some like firewall or routing tables or something. So if you have to restart the services, I'm assuming this is going to be a fast boot, is it better off to just always reboot the whole thing anyway?
Well, it depends. I mean, if we're talking real servers, I mean, a current generation G8 HP takes around 5 minutes to go through post. It's the system itself might boot quickly, the BIOS doesn't.
I think if you're talking,
EFI.
if you're talking about something that's
freaking slow.
Yeah.
I think if you're talking about something that's an actual server rather than a cloud instance, then it's still worth thinking of reboots as a somewhat planned thing. It would, for instance, be helpful to be able to apply updates automatically. A lot of people like to do that, but not necessarily reboot outside maintenance downtimes.
Good point.
I mean, some of the other things we mentioned in earlier sessions today, as well as while discussing system images for servers, is a few technologies coming down the line that we might look into integrating in that solution at some point. Probably not in the early iterations anyway, but still, where we could, instead of doing a full reboot, we could use kexec, which should bypass a good chunk of the reboot cycle, and more specifically bypass dual BIOS or EFI state that's really, really slow. The other thing that was mentioned was checkpoint restart, where we could serialize the application states down to disk, reboot and restore that state really quickly, so that even if you are running some pretty big server apps that take a long time to start, we can minimize the actual downtime by doing a quick serialization of that state down to disk, then kexec into the new system, and then restoring the app, probably doing like a full upgrade cycle in less than 20 seconds, and without actually losing any network connection in that process. But that kind of technology is still being actively worked on at the moment. We can serialize some stuff, we can serialize everything. So I don't think it's something we're likely to have in the first iteration anyway.
So does that type of capability give you the option of teleporting those apps, moving them to a different server, doing your reboot, and then moving them back? So the kind of live migration concept as well, yeah?
Yes.
Okay.
Yeah, the main reason why we are looking into that that kind of technology at the moment is for LXC, container live migration.
Yeah.
But the way the tool is actually designed is serialization of any Linux process. So while we want to use it for self-contained container, we could just as well apply that to any workload. Yeah.
That sounds awesome.
So yeah, one thing I think that Colin mentioned earlier and that we discussed a few times before this session is basically how the actual workload would look like. And I think, at least initially, the most likely things we would support on top of that Ubuntu Core image-based system is probably one of three things, or maybe just all three of them. I don't know. Which would be click bundled server applications. So similar to the phone, things are distributed as click packages through a click app store. Those are installed into a path that's writable on the file system, and they don't touch anything on the system itself. So we can do system images of the whole system without having to really care about them in any way. The other thing that we probably may want to have by default is the Juju local provider, where it's basically the same thing as the JujuD for a local provider. The only thing it actually all it stores on disk are basically LXC containers that are self-contained in one directory, which we can make writable, and so we can upgrade the whole system that doesn't mess with anything, and we're all good. And the third thing would be just install LXC itself, so that people can use that as an LXC host or through any of the tools that let you deal with that. As we mentioned earlier, actual standard package installs on that is really tricky to get right with the base system being read-only. We discussed a few options with Michael Vogt and the others a while back, but I don't think there's a magic solution around that at the moment, and it's probably not what we should be looking into initially. People who actually want to use apt-gets are way better off just using the Ubuntu server as we have today, or installing with an image, then putting it into read-write mode and use apt-get from that point on. Looking at the IRC discussion, seems to be quite a bit going on there.
So one thing that we do need to make sure of is that there's a way to install services as click packages, which is not currently possible. This means that we need the facility to install a click package that attaches to a system hook that lets them provide upstart jobs or systemd units. I'd actually like to float the idea that maybe this should be systemd based from the start. It's a new image. We know that we want to be heading towards systemd for everything else anyway. If we started out with upstart jobs, then we have to deal with the transition for the click packages that affect it later, or else we have to invent some kind of intermediate format, which hasn't really gone well when people have tried to do it in the past. I think it would be better just to say you provide a systemd unit and give us the path to it. Does anybody object to that path?
No, sounds entirely reasonable to me.
Yeah, since this image is probably going to be like a preview test kind of thing for this cycle anyway, I think it's probably fine going with systemd right from the start.
Yeah, +1 for that. As far as letting the, I think you said you let the click package provide the systemd unit. Do we think that? So one of the things is that systemd units, I believe, let you configure things like the C groups. Actually, I guess I'm not entirely sure of that, but I think like the resource limits and things are specified within the systemd unit itself. Do we expect completely unfettered control over everything? Do we think we need to be filtering what directives a systemd unit is allowed to supply? How do we think that's all going to work?
Yeah, so one, I guess from a click architecture point of view, what I'd like to see is that we have people provide their service directive in that file format, but there's room to apply a filtering pass to that. So if we decide that that some directives are forbidden, then we can filter them out at the point when the system hook runs to install that path in, or to install that unit file into somewhere that systemd will actually see it. I don't really know enough about systemd to know whether there's a way to kind of pre-confine things in a sort of ulimit style. It does sound like we might well want to have some filtering in the way through.
Okay, yeah. So I mean, the other thing is, I know we've talked about possibly wanting things like namespaces, network namespaces in particular for these kinds of services, which I would expect to be applied as part of the system to unit config, since really if it's being done as a system to unit, that's you have system D and then you have the unit and that's it. There's nothing, there's no intermediate layers, and system D supports namespacing primitives directly. Which I would think we would want to use, and so if we were doing that, we would not want to let the app provider interfere with that.
So systemd does provide a bunch of security options that might be interesting to use. However, so if we want to give the actual namespacing options of systemd basically just let you unshare an empty namespace. It doesn't let you configure it in any meaningful way. So if you want to, say, VTH0 in that namespace map to something else, systemd doesn't do that. We might want, I'm not sure we would do it in that case. I agree, so perfectly agree with Colin that we probably should just do systemd by default for that stuff, but I don't think I necessarily agree that we should ship the actual unit directly in the click. We might want to have the click contain an intermediate format that defines exactly what the app needs and then generates the actual unit on the system based on that intermediate format.
That's sort of what I'm saying, except that I think the intermediate format should be usable as a systemd unit file, just to make it easy for people to test. It saves us documenting another format, etc. But that we filter it to impose our own requirements. And the way that click hooks work, that's entirely possible.
Yeah. So you would need to filter it and extend it as well.
Sure.
So we would need to block some options. We would need to require, for example, that an application that let's say a firewall or something that needs to be called through a wrapper tool or something like that, and we need to have the configuration for that wrapper in question. But I believe systemd units are just standard INI files, aren't they?
Right.
Right. But this is essentially what we do with desktop files today.
Okay.
Which are the equivalent for applications. People provide them in desktop-ish form, and we mangle them the way through to make sure that they do things like calling the app has to be called under AA exec click at the moment on the phone. And I think the same design ought to work well for this kind of thing.
Yeah, I think we'll basically want everything to run through something similar to your exec click tool that then parses whatever else comes from that config and applies those limits. So yeah, that makes sense, and you can probably do something similar.
What about the matter of service configuration? So a lot of existing services that you might want to install are not really laid out in a way that works very well with this kind of thing. So they have, for example, it's commonplace to require that people edit a configuration file somewhere. Quite often, you in fact ship a default version of that configuration file and then expect that changes to it are merged on upgrade. None of that seems like it would work very well with click packages. So I'm not sure what we would want to do there.
Yeah, that part is still a bit blurry to me. I expect at least the early click packages would be rebuilt version of whatever software they contain, configured to look up their config from whatever writable path you get for the configuration with click, and Yeah, obviously you're going to run into problems as soon as you want to do major version upgrades, because there's no notion of upgrades book or upgrade script or anything like that in Click, right?
Well, yeah. So
Well, kind of. There are hooks that are run to catch the system up with the state of Click packages. They're not specifically run on upgrade of any single package, but they're expected to catch the system up with the current state. It's more like duplicate triggers. However, those are provided by the system, not by Click packages. So they would allow you to catch up, the systemd unit directory state with the list of Click packages that are installed and active, but there's nothing that a single Click package can deliver to be run on upgrade. And yeah, we might want to look at adding something like that.
Yeah. So the other obvious thing that those Click packages could do is, rather than have the user directly modify the actual configuration file of whatever they packaged, to go through more of an appliance-like kind of model, where they actually, the script that you call to start the app actually generates the configuration at startup time based on another configuration file that the user actually fills in. With that configuration file not changing massively between versions, and having a minimal subset of the options that are relevant to the actual use case that the Click package covers.
Yeah, I mean, Loic is asking which services should be Clickified, and it's sort of, I kind of feel that maybe it would be a distraction to actually try to turn existing traditional server packages into Click packages, because, for example, we'd end up having to rewrite lots of documentation that tells people which configuration files to edit. I don't think it's a sensible use of our time to be rewriting Postgres documentation to say that you need to write things into this different place because we moved everything around, that kind of thing. But the initial targets for this are for new services, so things like not the kind of thing that has traditionally been delivered on Ubuntu, but things like web services for small embedded servers, that kind of thing, rather than, say, Apache or MySQL or something. It would be the sort of thing that's much more standalone and which tends to manage its own configuration in maybe a little SQLite database or something.
Yeah, I think it makes sense that the at least early use case for that would be more closer to what people have been doing in the past with VM appliance kind of thing, where you indeed have like everything that the appliance itself needs bundled together with just minimal user editable configuration, and the rest are basically happening from the web interface or something. That would work pretty well with that model, I think.
Yeah, I mean, if you took this in the context of more image-based workflows, so things like Docker and the fact that we have this orchestration tool called Juju, if you tie those two things together, I'm not necessarily saying tie Docker and Juju together with the fact that we can do image-based updates to the underlying server, then that becomes quite powerful, because you can have Juju orchestrate the upgrade process. If you need to do image upgrades and apply new configuration in, but maintain underlying states, then I think they should be longer-term objectives that we should have to be able to do that type of operation. That was very hand-wavy and a bit vague, but I can kind of see how that might work in my head in terms of, I've got my app which needs to be able to store data, and I need to be able to apply configuration for the deployment that it's in, but that's more service-centric, so it's not Apache, it's my big web application supporting my company or whatever it might be.
Well, I mean, maybe one of the standard web app frameworks would be better things to start with.
Yeah.
So I think definitely the other use case for that thing is basically what I've been doing with servers for quite a while, except that are not read-only at the moment, which is basically just get me a simple Ubuntu server-based system with it could be LXC or it can be any other similar technology pre-installed in it, just read-only, and then you just deploy your containers on top of that. When you want to move machine, you just move those away somewhere else.
Yeah.
And yeah, having the base system managed with Steam image for that case is great, because I don't like having to care about the actual host because I don't actually use it. All my stuff runs on top of it.
No, and if you think about a lot of kind of scale out frameworks, they have a lot of stateless services. So your upgrade can be a throw away the existing image, put in a new one, apply the config, and add it back to the pool. That's a perfectly acceptable approach to that, and a common one to do. So you then kind of move away from the whole risk of in-place upgrades, which is quite nice. So, I like this idea. I think it's really nice, and I can see it being incredibly powerful. So we'll get to that, I'll say.
Is there anything being discussed on IRC which we should rather discuss in the Hangout? Or? Apparently not. So I guess we should probably take the remaining time in the session to actually figure out what we want to provide for 14.10, what kind of work would be involved, and who would do it.
Yeah, so far I've captured a sum total of one work item.
Yeah. So yeah, that's work item is for the upgrader itself. It's not necessarily even, well, it's going to be important down the line, but for 14.10, if we can't get that stuff working, we can always just do the same thing as we do on the phone. And yeah, okay, sure, it sucks. You need to reboot, but
so what are the other work items that we need here? We need the actual image creation, I suppose.
Yes, we need someone to set up a new live image build job so that we actually get an Ubuntu Core LiveFS image with the bits we need. So I need to look at what we actually have in Ubuntu Core nowadays, but I suspect we want to at least add a kernel, a bootloader, system image, AppArmor, and possibly LXC and Juju on top of it, just so that we get like a good starting point.
Okay. And Stefan, so will you take that action?
Sure, yeah.
Okay.
Also, initially I want to. Sorry, what was that?
Oh, sorry. I said like we need a work item for the hook support for the unit systemd unit files.
And that's a click hook, right?
I suppose so, yeah.
Okay.
So yeah, once we get the actual image built, then we can import it into system image. That side shouldn't even need any code change compared to what we have on the phone, so that should be fine. What we'll need, however, is for someone, I'm hoping maybe we can steal some of Sergio's time on that, to update the Ubuntu device flasher tool to actually create the image, either an EMG file that you can use with a VM or write that straight to a USB stick.
Sorry, I'm not sure I caught that whole thing. Can you record that? Can somebody capture that as a work item in the?
Yeah, so I think it would be for Sergio to add image, well, to add support for that image into Ubuntu Device Flasher.
Okay. And I'm not sure if that's something that Sergio would be working on.
The systemd. I'm sorry, I'll take the systemd hook file things. So I was essentially intending to write that anyway.
Okay, thanks. I wasn't sure if that was going to be you or Michael. Adding the support for this image type, I'm not sure if this is something Sergio would have the time to work on with us, or if he's going to be busy, because his primary responsibility is to the phone, of course. So with RTM, he may not have time for this. So I'll leave his name there, but do we have a fallback for who should take that if not Sergio?
Do we have anyone who does Go development?
I'm sure we will find somebody. Okay, we'll figure that out.
So yeah, once we actually have that image, then, or maybe one thing we should also discuss is basically the scope of that. Should we just build MD64 for now? Or do we want to bother building both 386, MD64, and maybe some other things?
Let's just. Does anybody object to just keeping it MD64 only for now? I mean, this is mainly a prototype tech demonstration.
Yeah, I would definitely agree with just MD64. It seems to be the obvious target, at least initially.
Yeah, that's certainly, I would say, prototype on MD64 only.
Yeah. And I guess we should prototype on having both BIOS and EFI support then on MD64.
Yeah, I think that's probably required to make VM operation sensible.
Mm.
I mean, I know you can do OVMF, but it's more hassle to set up.
Yeah, I think one of basically two options are either we just do BIOS or we do BIOS and EFI. Doing just EFI, I think, is not realistic at this point because of VM technologies and people running on older hardware.
Yeah, we could just do BIOS, but it's not very forward-looking.
Yeah. Okay. So hopefully with that we can actually have something like boot. I guess we need a work item on the actual initRD part of that. So setting up all the mounts and everything. It should be similar to what we have on the phone, but I suspect we need to do some splitting. I would like to kill LXC Android config as part of that because we tag the name, and we should have those lists of writable config files and writable paths and everything in something slightly better design, I think.
Well, and the writable paths thing is a disaster anyway, but...
yes, it is,
but
yeah. Anyone is welcome to come with a better approach to it.
Yeah. So the existing phone initRD it still uses init ramfest tools, doesn't it? It's just a severely enormous set of hooks.
It's just a single hook, but a pretty big one, yeah.
Sorry, yes, okay, a severely enormous hook.
Yeah, we use it's a boot script called it's script touch, I think, and then it doesn't do that much. It's massive because it supports like 3 different ways of setting up your device. It supports still the old Android flipped model. It supports a lot of weird things we don't care about. So yeah, it might be worth getting rid of half of it in the process as well. And basically, all the script does in the initRD is mount the root file system read-only, parse whatever it needs to parse to generate the FS tab, and mount that FS tab as a bind mount on its CFS tab, then exec init and done. It's in theory not that difficult. The problem is that we've got extra stuff that was added in there to do the old /custom stuff to apply vendor customization and kind of stuff that we probably don't care about for server just now. Okay, so I just added a work item for me to figure out the old bind mount and everything so that the system actually boots read-only with the right base mounted read-write. So if we get that, then we get into system image itself, which, well, Barry might correct me there, but I don't think system image itself really requires any work for that, right?
For which specifically? The read only?
Yeah, updating a server basically. So getting the right files for an image update on the server.
The only thing that, and I added a couple of work items for this, the only thing that needs development is the actual, we've got all the files, what do we call to actually apply them? Mm-hmm. And then there's a little bit of work to separate out the apply and reboot steps. I assign,
I think the first thing we would do there, just to get something running really quickly, is basically keep it the same way as we have on Android, and reboot the system into a mode where it's first run the script the same way we do on Android for the upgrade, then continues booting the system. And then once we get that part running, we can look into getting that script running on the actual system rather than separately from it.
Yeah.
So yeah, that should get us a working system we can update. They're still getting Grub installed, running, and all that stuff, but yeah, got another work item for it, I think. And then maybe getting stuff actually working on it would be nice. So those then are the click work items, I guess. Yeah, click hook support for systemd files. Do you need anything other than that, Colin, to support server kind of workload?
We may well want more eventually. So the other obvious thing that we may need is the ability for click packages to provide facilities to other click packages. We talked about that a bit in Malta, and I do have a to-do note for myself to do that. So at present, hooks can only be provided by system packages, but perhaps click packages that are sufficiently unconfined ought to be able to provide facilities to the rest of the system, and that would allow people to that would allow us to ship a single common root file system, but give others the ability to extend the facilities it provides without having to rebuild the whole image.
Okay. So we've got 3 minutes left. I think one thing that Ricardo mentioned on briefly on IRC that we didn't really talk about is the partitioning scheme for that thing. I guess it's pretty fair to assume that the initial implementation, we basically just want to write a bootable system on a USB stick and have it basically update on that. That's, I think, the easiest thing we can support initially, and later on what we would probably do is have a script that then dumps that into onto a physical hard disk. I'm not sure, I don't think we want to care about dual boot or anything like that at this point. And the actual partitioning of the USB stick, I'm not sure whether we want to discuss that now or we'll just figure it out later.
Yeah, I mean, we're going to need an EFI system partition on it, but otherwise.
Yeah. There's going to be, so quick question there. Can we always have the USB stick be GPT with a reserved slot for BIOS for the MBR plus an EFI boot partition and have that work on both EFI
Well,
and x86.
just use the same strategy that we use for our desktop images today. They're hybrids. CD, USB, etc.
Right.
Let's not reinvent that wheel. It's really boring to have to go through all of the corner cases. We should just use I think we should just use the same hybridization approach there, because we've debugged it to a pretty fair extent, and any further debugging that happens ought to happen on both.
So that means we won't be running Grub install then, because you can't possibly run Grub install against the madness we've got on our ISO images.
Well, no, I mean the formatting when we install it to a fixed disk doesn't have to be the same. It doesn't have to be the same partition format as is used on the. It doesn't have to be the same. Particularly the boot record partition table level doesn't have to be the same as on the USB stick.
Right,
and probably
but
shouldn't be.
Yeah. So the question is, do we actually want to write the tool to install that onto disk at this point, or is that outside the scope for the original tech preview?
I think we need to do something for that, but I think it ought to. I mean, I thought we were running that in the analog to the recovery image, so an init.rd or a separate recovery system or something. I didn't think that we were. I don't see how we can have that be entirely in the system image level of things. I think that has to be done on the target system.
Yeah. So because I think Alexander mentioned using basically being able to update your USB stick as you would an actual system.
Sure. I mean, it's sensible to be able to do that, but we should expect, I think, that there are different boot arrangements on the two.
Right. Yeah. So for the USB stick itself, should we then consider the MBR part of it as being a binary image that we ship as part of the update, and we just DD back at the top of at the beginning of the disk every single time?
Yeah, I think if we. I'll need to refresh my memory on exactly where everything goes. I think that in fact, our USB images at the moment boot using, well, they boot using syslinux on BIOS and Grub on EFI. Syslinux is it has a sufficiently simple config file format that I think we could just update the configuration file and not worry about the actual bootloader binary, and Grub lives in the EFI system partition. So both of those should be reasonably straightforward to update.
Yeah, if we never need to update the Syslinux binary, then it's quite a bit simpler indeed. Because, yeah, as I said, the EFI binary is just writing a file on the file system. That's simple.
Yeah, I mean, if we wanted to overachieve, we could try to work out which region of the hybridized MVR was occupied by isolinux.bin and update that. It should be possible,
the
but
other trick is,
I don't think we need to do it.
The other trick is, if we go down that way, the dual hybrid thing assumes ISOFS with squashfs, right?
The hybrid stuff is higher level than that, or sort of further out in the image. It doesn't particularly assume squashfs now.
Okay, because yeah, I wonder
it does assume that
it's to write to it.
Well, it does assume that it's an ISO, that it looks like an ISO 9660 file system at the top level. And I'm just trying to think how. So I think the ISO 9660 part of it, the part that's represented there, does need to be. I don't think we want to be trying to update that from Linux, but if we can keep our rights to an area that we can sort of fence off from that.
Yeah, I'm not
I
sure.
can't quite remember enough how it works just in the spur of the moment.
I remember enough to be a little bit twitching about trying to keep the hybrid in place. Unless we specifically expect to be booting this as a CD, which I don't think is on the roadmap right now, I think we're better off just creating partitions, MBR, UEFI system partition, and not doing any of the hybrid stuff, since the hybrid does involve the ISO 9660 and.
Right. So basically having
Well,
the device flash in that
Yes,
case,
fair
create the
point.
USB stick for either BIOS or EFI at creation time, and not try to be an hybrid.
Right, because I mean, we certainly do still have bugs in our hybrid support in various configurations.
We do, yeah. Okay, yeah. Maybe it's better to do that at the flash layer and just deliver the main partition with our in our image builds.
Seems reasonable. Okay, so we're at time for this session, though. Do we need to schedule further discussions? Is this something we'll just take offline for anything else?
I think we've got enough work items to try and get a prototype core image, working system image at least. And I think that's realistically what we, pretty much as we can achieve this cycle, I guess, at the moment.
I agree.
Right. And I think the target for this cycle is definitely prototype space, not production ready. If anybody thinks of anything else major that's missing out of there in terms of work, please add it in. But otherwise, great session, and we've got some good work items out of it. So.
All right. Thanks everyone.
Thanks.
Thanks very much.